Dear student, welcome to the fresh topic, Rutherford Alpha Scattering Experiment. Very important topic. Why? Because the reason is, due to this experiment, Alpha Scattering Experiment, which is also known as gold foil experiment, okay, we got nucleus idea. That what is nucleus? We got positive charge, I mean proton idea. We got the idea of internal part inside in an atom. Okay, that is why this topic is very important. So, let us start this topic with important points now. What happened? Rutherford designed one experiment where a fast moving particle, which is called alpha particle, made to fall on thin gold foil, very thin gold foil, okay, and the thickness of that gold foil is 100 nm, 100 nanometer nm, this much thick, okay. And what is alpha particle? Alpha particle is nothing but helium plus 2 ion, helium plus 2 ion, or you can also write it in this way, helium plus plus, both are same only. This is called alpha particle, helium plus 2 ion is alpha particle, okay. And they have 4 unit mass. See, helium has 2 atomic number and 4 mass number. So, it has 4 unit mass. So, the fast moving particle, it has considerable amount of energy like kinetic energy, potential energy, total energy like that, okay. Alright, let us see the setup what he made for the experiment. See, this is called movable screen, this circular screen what you are seeing, okay. This is zinc sulfide movable screen, okay. You can move it at 360 degree, no issue. This is gold foil, this foil is gold foil, okay. And what is this? This is the source, okay, from where alpha particle is originating. And what is this part? This 2 rod, what is this? This is the slit system through which the ray will cross, right, okay. Or you can say this is polarizer or this is concentrator. What is the work of this slit system? All the rays what are spreading in different directions, okay, this slit system will concentrate the ray in one dimension, that is it. This is called slit system, alright. So, this is the setup of alpha scattering experiment, and these are the rays, alpha rays, beam of alpha particles. What happens when alpha particle will touch the gold foil? After that, so many things are observed. What we observe? That light is deflecting at different angles, okay. See, I will tell you the observations and all, not an issue. So, my main motto here is to show you the setup what Rutherford did here for the experiment. Let us see some important points about the experiment now. What happened when he did the experiment? Then most of the fast moving particles passed through straight line in the gold foil, okay. He bombarded, see, so many books says 20,000 alpha ray he bombarded, few books says 12,000, few books says 18,000, does not matter. Simply it was like more amount, high amount of alpha ray he bombarded towards the gold foil, okay. Under 9th, 10th we study 12,000, when you go to 11th class in NCERT they are writing approx 18 to 20,000. So, it changes book by book, does not matter, okay. What happens when, if this is a thin gold foil, okay, and here alpha ray bombarded, few of the alpha ray are deviating at large angle, okay, like this. It should go straight because ray should travel straight, but it is deviating at this angle, few 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 deviating at this angle, like that, okay. So, at different angles it starts deviating, okay. And what happened? One ray, it is observed that one ray is going towards the metal and not able to touch the metal and returning back, okay. We can say at 180 degree returning back and not able to touch the metal. But only one ray in 12,000 rays or in 18,000 rays, only one ray is showing this behavior. What is the behavior? I repeat, important behavior. Ray is approaching towards the metal, and after some time without touching the metal at some distance d, it is returning back, retraces its path, rebouncing. Okay, this happens. This is what in experiment we observed. Okay, now on the basis of observation we come to the conclusion. Let's see the next important point of alpha rays. What happened? The conclusion of this experiment is, because what happened, so many rays are deviated at different angles, but most of the alpha ray were not deviating. They were going simply straight. They were going simply straight without any deviation. Most of the alpha ray did not deviate from its original path, which shows that nobody is in the metal to deviate these rays who were going in the straight line. It means the atom is, most of the part inside the atom is empty. Okay, because nobody was deviating these rays. Okay, let's see the second point of the conclusion now. Very few alpha particles were deviated at small angles, at some angles, very few. Okay, question comes, why deviated? So understand, see this part. If we talk about this circle, okay, suppose this is the center of the circle, and what happens, alpha rays who are far from the center, okay, they were going straight line, in a straight line without any deviation. They were going in the straight line, no problem. But when those kind of alpha ray who were crossing from nearby the center, they were feeling some kind of repulsion and deflection. So if the ray is passing nearby this nucleus, they were feeling huge deflection. If the distance from the nucleus increasing, then less deflection. And if distance is very large, okay, at more distance from the nucleus, then no deflection. What I want to say here, you can observe something. Why? Because alpha ray is already positive, so we can conclude that definitely any positive is repelling this positive ray, and that positive is at the center, because when ray is crossing nearby center, then we feel more deflection, more deviation. That is why we observed that heavy, dense, positive particle is at the center of the atom. Okay, all right. And one ray in 18,000, one ray is not able to touch the metal and returning back, because here is positive, the maximum repulsion will be experienced by this ray. That is why it is not able to touch the atom. Remaining rays are crossing, no problem, but one ray is not able to touch, because heavy, dense, positive charged particle is at the nucleus. That is why it is feeling maximum repulsion, who is approaching directly nucleus, not able to touch the nucleus. Understood? Okay. So this distance, I mean, suppose this is the atom, okay, and ray is coming and returning back. So whatever this distance is known as distance of closest approach, this R. Let's see the third conclusion of this experiment. Okay, as I told you, the deflection of one ray in 18,000 or in 20,000 or in 12,000. See, important question is why that ray is not able to touch the metal, whether the at same time other rays are touching the metal and crossing the metal easily, few with straight line, few with at some angles deviated, but this ray, why only this ray is not able to touch the gold foil? This was the question, and due to this question only nucleus discovered, positive charge discovered. Okay. So that is why this experiment is the base of discovery of the nucleus. By the way, you understood all these three conclusions. Let us study the drawback of this experiment now. According to the classical quantum theory, okay, what it says, this theory says. So quantum theory says that if any charged particle moves under acceleration, then it radiates energy, it emits energy. Okay. So at some time, after some time, okay, it will lose the energy. Okay. Energy can neither be created nor be destroyed, it is okay. but we can transform the energy from one form to another form. So, this energy, I mean the energy due to which the body is rotating, the charged particle is rotating, that energy will decrease. I mean classical theory says that. Okay. Now, that theory if we apply here, that electron is moving. Okay. So, when electron moves, then it will also radiate the energy, it will also emit the energy, and after some time due to its rotation it will fall inside the nucleus, it will hit the nucleus, but it does not happens. So, Maxwell theory is not fitting here actually. Okay. So, as a result the orbit will like small, see at first I had this orbit, this size orbit, then I have bit smaller orbit, then bit smaller, very small orbit. So, my orbit size is decreasing as time to time and hitting the nucleus at one time, but it never happens. So, this theory, Maxwell theory is not fitting here. That is why this is the demerit of his model actually. Rutherford model is also known as solar system model, and this however does not happen, I mean electron does not hit the nucleus. So, this theory has some demerits. So, Rutherford Alpha Scattering Experiment is completed now. You saw the experiment setup, okay, and what they performed in the experiment. I hope you understood the lecture. Thank you for watching.